2025 A-Level Combined Mathematics Paper 1, Part A, question number 3. This question has to do with complex numbers and Argand diagrams. The question says, first, sketch in an Argand diagram the locus of the points that represent the complex number z, satisfying the equation modulus of arg z minus 2y equals pi by 4. It then says, hence or otherwise, which usually means hence, find the minimum value of modulus of z minus 1 for z satisfying this given condition here. So first off, analyzing the first part of the question, we can see for the Argand diagram bit, we are asked to find the locus of the point such that the modulus of arg of z minus 2y is equal to pi by 4. So if the modulus of arg of z minus 2y is equal to pi by 4, it means that the arg of z minus 2y could either be plus pi by 4 or minus pi by 4, since when you take the modulus of both of those numbers, you get pi by 4. So therefore, this implies that the arg of z minus 2y is equal to plus or minus pi by 4, which means there are two possible values that you could have. You could either have that the argand of z minus 2y is equal to plus pi by 4, or the argand of z minus 2y is equal to minus pi by 4. Meaning that in this particular case, usually while an argand of a particular complex number equaling a certain other number gives you a straight line, in this case you're going to get two straight lines from this equation, since one of the straight lines is going to be when the argand is plus pi by 4 and the other one is going to be when it's minus pi by 4. Now, looking at the inside, the argand of z minus 2y is going to give us all the angles of all of the points that are translated from a certain value downward until they meet the origin, and that value is 2y. So the point at 2y is going to be translated towards the origin. The point that's 2y plus 1i or 3i is going to be translated towards I. So all of the points here are going to be translated down before you take the argand of them, and due to that the original points are actually up from the origin. So if you just take arg of z equals pi by 4, then the line you get is this line like this. But since this line is corresponding to all of the points that are z minus 2y, to get the original line you need to add 2y, meaning that arg of z minus 2y equals plus pi by 4 is representing the points starting from the point 2y, which is somewhere up here. I'm going to mark it as 2y, and going upward with an angle of plus pi by 4 on it. So therefore, relative to the real axis direction, plus pi by 4 is the direction of one of the lines. So this line is the line corresponding to arg of z minus 2y equal to plus pi by 4. There's also a minus pi by 4 case. In that case, the angle of the line has to be minus pi by 4, but once again, because of this translation of minus 2y, this thing is once again going to be translated to this origin from minus 2y, and then we're going to take the argand to be equal to minus pi by 4, meaning that if you untranslate it, the original line would have been passing through plus 2y and going downward with an angle of pi by 4. So now, if we consider the rest of this diagram and we'll draw a few other points that are going to be important for our solving, we're going to have the origin here, which is going to be represented by 0, and if we consider this line passes through the real axis, and since this angle is 45 degrees or pi by 4 radians, we can see that it's going to be passing through the real axis at the value of 2. So therefore, this is 2y, this is 2, and here it is important that you mark this hole and these angles correctly. So this angle is pi by 4 above the real axis direction, this angle is pi by 4 below the real axis direction, this point here is 2y, and importantly, this point has a hole in it. The reason that the point has a hole in it, of course, is because you cannot have an argand of 0. The argand of 0 is undefined, and for that reason, there's a hole at this point. So now, this is pretty much what we're going to be drawing for the Argand diagram for the first question. The second part of the question requires us to draw a bit more. So for the second question, they are saying, hence or otherwise find the minimum value of the modulus of z minus 1 for z satisfying this thing. So our z value is going to be something that is satisfying this equation here, meaning that it is either on this line here or this line here. So we need to look at only the points that are on this line and this line. So for these two sets of points, we need to find the minimum value of modulus of z minus 1, which is basically the distance of a point z from the point 1, as in if you consider subtracting two complex numbers, you're basically getting the complex number vector that leads from one point, in this case the minus 1, up to z. So basically we are asking, what is the distance between the point 1 and the point Z, and we're asking what is the minimum value of that distance. So we're basically looking at the point 1 over here, and we're looking at all the points on this line and looking at which point has the minimum distance to this point here. Well, for this line, the minimum distance is going to be at the perpendicular distance point, which is going to be this point over here, which is going to have the property that it's going to lie on a circle like this. So we know it's definitely going to lie on this circle, which has a certain radius which we don't know, but it is centered at the point 1. Now it's important to note that you should probably draw this circle with a compass. I'm just drawing it with the pen because I don't really have a compass with me. That's easily drawable in this software. So you draw this with a compass around the point 1 that touches and goes tangent to this line here. Now obviously this point Z that we're looking for cannot be on this line here, since if it was on this thing, then it would have a greater distance from the point 1 compared to any of the points on this line. So for that reason, this must be the point that we're looking for, this point right here. Let's label this point that we're looking for Q. Let's also call the point that we're starting from P. Let's additionally label this point here as R, the point where this circle touches the real axis, and let's label this point here as S. So now let's take these points and let's establish some connections. So first off, the main connection is the connection of this length PQ and what we're looking for. The minimum value of the thing we're looking for, which is the modulus of Z minus 1, that satisfies this equation here, which I'm just going to write as satisfies the above, since I don't really want to write it again, the above, is PQ. Since we've just drawn it like that, and that is what we're looking for. So the length PQ is equal to the minimum value of the modulus of Z minus 1 that we've been looking for. So we're establishing the connection. Now we can stop thinking of this as a complex number problem and start thinking about it as a geometry problem. So we know that the center of this circle is at the point 1. We know that this line is angled at pi by 4 radians, and we know that this point here that it touches the real axis is equal to 2. So now with this information, we can take this PQRS triangle bit outside here and solve it geometrically. So here, this point is P, this point is Q, this point here is S, and some point in the middle here is R. Now what we know about these points is that this point is at 1 and this point is at 2, meaning that the length PS is equal to 1. Since 2 minus 1 is equal to 1, and this is horizontal. So PS, the length PS is equal to 2 minus 1, which is equal to 1. So this length is equal to 1. Now, we also know that this angle here is 90 degrees, and this angle here would be pi by 4. The reason for that is that this angle here is also 90 degrees. Why is it 90 degrees? Well, this line here is running tangent to this circle here, because this line here is the perpendicular to this line here. So for all of those reasons, this is 90 degrees because this line is running tangent to the circle that encompasses this radius of that circle. So now with this information, we also know that this angle here is also pi by 4 radians. How do we know that? Well, this is pi by 4 radians, and this line and this line are perpendicular, so parallel to each other, which means that this angle and this angle will be equal to each other. So this angle here is also pi by 4 radians. So now with this information, we can now find the length PQ that we're interested in. How can we do that? Well, we can see here, this is 90 degrees, this angle is pi by 4, and the hypotenuse here is equal to 1. So if the hypotenuse here is equal to 1, we can see that PQ is going to be equal to the hypotenuse, which is 1, times the cosine of pi by 4, since this right here is a 90 degree triangle. So therefore, we can see that PQ is equal to 1 times the cosine of pi by 4. And the cosine of pi by 4 is 1 divided by the square root of 2. So we have 1 times 1 over the square root of 2, which is equal to 1 over the square root of 2. Or we could write it nicely with the denominator being rational, and we could write it as equal to the square root of 2 divided by 2. So that is our final answer. After all of this, after drawing the Argand diagram, after establishing the connection between the complex numbers and the geometry, and finally solving the geometry to find the actual length that we're interested in, we have solved our question. Now, you don't really need to at this point say that this is the minimum value of z minus 1's modulus, since we have already mentioned that up here. Now some of you might think, oh, I need to write that the minimum value of z minus 1's modulus is equal to this. No, you don't. You've already said that. So at this point, our solution is pretty much complete. Now one thing I should mention is that when you're doing a solution like this, you need to be aware of your space. You have limited space and you need to draw a diagram, maybe another diagram here, and write a bunch of things. So in my case, even though I'm doing this in a software and have a certain degree of flexibility, I have still run into a bit of a problem with space. This thing is kind of clashing with my graph and all of that. However, it's kind of alright. So my advice to you is to make sure that you plan out the space that you're going to need for your question before you actually write anything. Furthermore, another thing I'd recommend is that when you're drawing the graph, try and draw the graph one shot. The proper way to do this would be to practice multiple graphs until you perfect it. Because if you draw the graph and you draw it incorrectly, you're going to have to spend a long time erasing it, and that's going to waste your time. So anyway, this is our final solution for this question. So now finally, let's take a look at the answer's total marks. For the Argand diagram, for this hole and a bunch of these coordinates, you're going to be getting 5 marks. For this graph line here and this graph line here, you're going to be getting 5 marks. And for this circle here centered at the point 1, you're going to be getting another 5 marks. As for the rest of it, for this logic here where you're relating the variables and the geometric and complex number parts together, you're going to get another 5 marks. And finally, for solving the geometry and getting this final answer, you're going to get another 5 marks. So you can see here an interesting thing. We're going to get most of our marks, a full 60% of our marks, from just the diagram. So for this reason, once again, I'm going to implore you to practice a bunch of Argand diagrams until you perfect it and draw it properly. So that's going to be my advice for you. If you have any feedback or anything else to say, post them in the comments down below. Thank you for watching. I hope you enjoyed, and goodbye.